This is part 3 of graphing quadratic functions, and in the last video we looked at this formula, f of x equals a times the quantity x minus h squared plus k, where the vertex is hk, and we talked about what the value of a does to the graph, how it affects the graph. If the absolute value of a is between 0 and 1, some kind of a fraction like a half or a third, it produces a wider parabola than your basic f of x equals x squared. If the absolute value of a is greater than 1, like 2, negative 6, positive 6, then it's going to be narrower. If a is negative, the parabola opens down. If it's positive, then it opens up. So if any of this is not familiar to you, you may want to go back and watch those videos. So what I want to talk about now is if you get a quadratic function in a different form. So I took an example here. F of x equals 2 times the quantity x minus 3 plus 1. And if we got the equation in this form right here, we could simply use the formula that's in this box to determine the vertex. And that vertex would be what? Let's see, our h value is 3 because we have a minus 3, which corresponds with our equation, our formula. H is 3. And our k value is 1. So my vertex is at 3, 1. And I know from my a value, being a positive 2, that my parabola is going to open up. And it's going to be narrower than f of x equals x squared. But now this equation, 2 times the quantity x minus 3 squared plus 1, it could be written in a different way, and that's what I've done here. If I take the x minus 3 and square it, x minus 3 times x minus 3, I get this trinomial, and then I could distribute the 2 into this trinomial and add the 1, that's where I got the 19. 2 times 9 is 18 plus 1 is 19. So basically I just took my original equation here and, did the order of operations and simplified it into a trinomial. This graph, 2x squared minus 12x plus 19, is the same exact graph as the original equation up here. It's just in a different form. So it would also have the vertex 3, 1. But to figure out what the vertex is, to get it into this form in the box, can be kind of a pain. And there is a way to do it by completing the square and things like that. But in this video, what I want to show you is another way to find the vertex other than this HK method. And it would be a way that you would use to find the vertex if the equation was in this form down here, which is basically f of x equals ax squared plus bx plus c. So in other words, if my f of x is in this form, f of x equals right here, let me bring in a new formula. This is what we want to use to determine the vertex. Okay, so if I have an equation in the form f of x equals ax squared plus bx plus c, this is a new formula here to help me find the vertex. A couple things I want to say. This formula can be derived. I'm not going to do that in this video. Most algebra books will have that derivation of y is it opposite of b over 2a, which I think is important. And if you've ever gone through a proof of the quadratic formula, it's a similar process. Secondly, the a value in this different form of the quadratic function is the same. All these things in purple down here that we know about the a value are still going to be true. Notice that, let's call, the old form right here. This was my old form, the one we had before, and this is the new form we're talking about in this video. Notice the a value in the old form is 2, and the a value in the new form is also 2. So that a value didn't change. It still tells us that the parabola opens up, and it's narrower than f of x equals x squared. But the hard part is determining the vertex. Okay, so the new way to find the vertex is to use this formula right here. The vertex is going to be at the x value opposite of b over 2a. So before we go any further, let's make sure we're really clear about how to find the a, b, and c values. And if you've done the quadratic formula, they're the same. The a is the coefficient on the x squared term, the b is the coefficient on the x term, and the c is the constant term. So in our example down here, A is 2, B is negative 12, and C is 19. So to find our vertex using this new little formula, the first thing I want to do is find the x value of the vertex, which is the opposite of b over 2a. So my b value is negative 12. The opposite of b then would be positive 12. My a value is 2, so 2 times a is going to be 2 times 2, which is 4. And 12 divided by 4 is 3. Now notice in my formula box up here, I say that the vertex is at opposite of b over 2a, which is my x value, and then I have a comma and I have a blank space right here. So to figure out what goes in that blank space, you simply have to plug in your x value back into your equation to figure out what your y value would be. If you don't have this stuff in purple written down, you might want to do that. Pause the video and do that because I'm going to erase it if you don't already know that stuff. We can see we're on the right track here because we know the vertex of this parabola is 3, 1, and using our new formula we came up with an x value of 3, so we know that's right. So to find the y value, we know the x value is 3, so we take 3 and we plug it into the function. F of 3 into this function right here equals 2 times 3 squared minus 12 times 3 plus 19. And if we did this right, it should come out to be 1, because we know from the old form, before I simplified it all out, that it was 1. Well, let's see here. We got 2 times 9, which is 18, minus 36 plus 19. 18 take away 36 is negative 18, plus 19 is 1. So that would give me my y value of my vertex. So technically, to fill in the formula, I would take f of whatever I got from my x value. And that's how I determine the y value of my vertex. Alright, let's look at another example. So if you think you got this down, you could pause the video and try it on your own here. So what I want you to do is find the vertex. What is the vertex of this parabola? F of x equals 2, let's go negative 2 x squared plus, let's do 8 x minus 5. Alright, go ahead and give that a try. Okay, so to find the vertex, we're going to first find the x value of the vertex using opposite of b over 2a. My b value is 8, so the opposite would be negative 8 over 2 times a. My a value is negative 2. So I have negative 8 over negative 4, which is a positive 2. So that is the x value of my vertex. Now I have to find the y value, and to do that, I'm going to plug 2 back into my function to determine the corresponding y value. So negative 2 times 2 squared plus 8 times 2 minus 5 would give me negative 2 times 4 plus 16 minus 5 would be negative 8 plus 16 minus 5, which would be 8. Take away 5 is 3. So my vertex is at 2, 3. Let's talk about some other characteristics of this parabola. Is it going to open up or open down? Well, we want to look at our a value for that. Here's our a value is negative 2. Since it's negative, we know it's going to open down. And since it's 2, is it going to be wider or narrower than a standard f of x equals x squared parabola? It's going to be a little bit narrower. Alright, let's see if we can draw a graph of this. I'm going to erase this part right here, so if you need that, go ahead and pause the video right now. Let's see if we can pull in a graph. Let's make it a little bit smaller so it fits. I'll just rewrite my vertex. We'll put it right there. Okay, so my vertex is at 2, 3. So we'll go ahead and plot that first. over 2 up 3. And I want to talk about a couple characteristics of the parabola. The first one I talked about in the previous video is called the axis of symmetry. What would be the axis of symmetry for this parabola? Well, it's going to go right through the vertex, and it's going to be a vertical line right through the vertex. So if I wanted to draw that, let's see if I can get that to come out in green here. That looks good. There's my axis of symmetry right there, sort of a reflecting line for my parabola. And the equation of that line, since it's vertical, is going to be x equals whatever the x value of this point is, which is 2. So that is the axis of symmetry. If I can find a point on one side of this line, I can just reflect it to the other side of the line, and that will give me another point. So to find points, I'm going to go ahead and plug in some x values that are close to my axis of symmetry, probably 1 unit away and then 2 units away. So 1 unit away would be x equals 1 or x equals 3. Either one of those numbers should produce the same y value. Let's go ahead and do 1. Let's find f of 1. So we're going to do some points now. So f of 1 would be negative 2 times 1 squared plus 8 times 1 minus 5. Alright, 1 squared is just 1 times negative 2 would be negative 2 plus 8 times 1 is 8, which gives me 6 minus 5 is 1. So if I plot that point 1, 1, x was 1, and then f of x came out to be 1. I get a parabola that's opening down. That's good because I was expecting that, and it looks kind of narrow. So now I can reflect this point over the axis of symmetry, and it's going to end up right there. I got 2 points. Alright, let's do f of 0. This should be easy. Negative 2 times 0 squared plus 8 times 0 minus 5. Well, that's going to come out to be 0 plus 0 minus 5 is negative 5. All the way down here. Okay, that's 2 steps away from the axis of symmetry, so I'm going to go 2 steps to the right and get a point there. There's my parabola. Let's see if I can draw that. There we go. Ooh, that wasn't so good. I kind of got off track there. Well, that's not the prettiest parabola, but hopefully you drew it a little more U-shaped than I did. Let's talk about domain and range of this parabola. If you need this, go ahead and pause it. Actually, I'll leave the axis of symmetry. Let's just get rid of this. Domain and range. So remember, the domain are the x values. What are the x values of my parabola? And the range are what are all the y values of my parabola. Well, if I think about the domain and think about how far to the right will this parabola go and how far to the left, it's going to continue opening and opening and opening. So it's going to go to the right to infinity and to the left to infinity. It's never going to stop getting wider. Even though it's a narrower parabola than y equals x squared, it's still going to get wider and wider and wider and continue off to the right and left forever. So the domain is all real numbers, which you could write like this. You could say the set of all x such that x is an element of the real numbers. You could say infinity. Wait, let me write that a little better. Oops. It just kind of depends on how your book or your instructor likes you to write the domain. You could use interval notation, negative infinity to positive infinity. That's a common way to write the domain. Now the range are the y values, so how far up does the parabola go and how far down does it go? Well, obviously it goes down forever, but it doesn't go up forever. It only goes up. It tops out at a y value of positive 3. So the range goes from negative infinity up to positive 3. Another way to write it would be the set of all y such that y is less than or equal to 3. All my y's are less than or equal to 3. Or maybe just y is less than or equal to 3. In my class and in the books that I use, we usually use this interval notation, negative infinity to 3 or negative infinity to positive infinity. So these are some characteristics you want to know of a parabola. If you were given an equation like this, f of x equals negative 2x squared plus 8x minus 5, you'd want to be able to find the vertex, find the axis of symmetry, draw a graph, determine the domain and the range, and you'd probably do them in that order. Let's try one more of these. I'll give you an equation and you can do all these things, alright? Vertex, axis of symmetry, plot some points, domain, and range. Alright, let's try f of x equals 1/2 x squared plus 3x plus 4. So go ahead and pause the video and see if you can work this out. Remember, what you want to do is find the vertex. Then you want to find the axis of symmetry. Then you want to plot some points. Do a graph. I guess I should have just said graph. And then determine the domain and the range. And when you're ready, go ahead and start the video. Okay. Let's see how you did. Put this down here. That's a good spot. So first thing, we want to find the vertex. We're going to use our formula opposite of b over 2a. Our b value is 3 and our a value is 1/2. So the opposite of b would be negative 3 over 2 times a, which is 1/2. So we get negative 3 over 2 times 1/2 is 1, is negative 3. So that's our first value of our vertex. Now we need to plug that negative 3 in and find f of negative 3 to determine the y value. So we got to do 1/2 times negative 3 squared. I guess I don't need that dot. Plus 3 times negative 3 plus 4. So negative 3 squared is a positive 9. And that's going to be a negative 9. So half of 9 is 4.5. Minus 9 plus 4 is negative 4.5 plus 4, which is negative half, or 0.5, whatever you like. Okay, so there's my vertex. Negative 3, negative 1/2. Let's go ahead and plot that. Negative 3, negative 1/2, about right there. Now I want to think about whether my parabola opens up or down just to get a picture of what's happening. So my a value is positive, so that means it's going to open up. And it's a fraction less than 1, so it's going to be a little bit wider. Maybe not that wide, but a little wider than a standard parabola. Okay, if you need this, go ahead and pause the video. I'm going to go ahead and erase it so we can work out some points. Alright, I need something close to my vertex at negative 3, so I think I'm going to plug in negative 2 and negative 1. Actually, 0 is a really easy one to do. So maybe even I'll do negative 2 and 0. Why is 0 easy? All right, let's do 0 first just to show why that's so easy. F of 0. When you put a 0 in for x, this first term is going to be 0. This second term is going to be 0. It's just going to be 4. All right, I'll go ahead and write that out for the sake of writing it out. But that's kind of a free one to put in 0 when it's in this form. When it's in the other form that we had at the very beginning of the video, it's a little more work. So 0, 4 is a point on my parabola. 0, 4. Oh, we were going to do the axis of symmetry next, weren't we? Okay, let's put that axis of symmetry in there in red. It's going to be right there. Oh, that's a little off to the side. Let me try again. How about right there? That's better. Alright, there's my axis of symmetry. So now, with my point 0, 4, I can see that that is 1, 2, 3 units from the axis of symmetry. So I'll go 3 units to the left and put another point. And I think one more point will be good, so either negative 1 or negative 2. Let's do negative 1. Okay, f of negative 1 is going to be 1/2 times negative 1 squared plus 3 times negative 1 plus 4, which would be 1/2 times 1, which is just 1/2, 3 times negative 1 is negative 3 plus 4. 1/2 take away 3 is negative 2.5 plus 4 would be 1.5. Moving back and forth between decimals and fractions, hopefully with a half, that doesn't bother you too much. So here's my point, negative 1 and positive 1.5. Negative 1, positive 1.5. That looks pretty good for my parabola. And then negative 5. So, okay, so this is 2 steps to the axis of symmetry, so I'll go 2 steps this way. And that looks like enough information to draw a decent parabola. Now, if you needed more points, you could certainly plug in more. That's a little better parabola than last time. Domain and range. The domain with these kind of parabolas where they're opening either up or down, there are some that open to the left or the right. They're not functions, but they're still parabolas. But the domain of parabolas that open up or down is always going to be all real numbers. Always. So that's pretty easy. The range pretty much depends on the vertex and whether it's opening up or down. So this one's opening up, so it's going to go up to positive infinity and basically down to the y value of the vertex. Did I erase the vertex from before? I did. Let me write it up there. So the vertex was at negative 3, negative 1/2. So the y value of your vertex really helps with the range. That's how far down it goes, down to negative 1/2. Or you could say that your y values are greater than or equal to negative 1/2. So there it is. There's all the characteristics of a parabola in this form. Oops, I just marked on my... This is a formula that you're going to want to remember, the opposite of b over 2a, and then that you have to plug it back into the formula to find the other value of the vertex.